Okay, so here we're working on the Khan Academy exercise, modeling with two variable equations and graphs. And what I've done is I pulled up the hint. We're going to work through this one together, and then I'll do another one here. This one says 3 gears are rotating together. So gear A has 7 teeth, and gear B has 9 teeth, and gear C has 6 teeth. So write an equation that represents the relationship between the number of revolutions gear A repeats, A, and the number of revolution gear C repeats. So what I'm going to do here is I'm going to actually just grab this whole thing. Let me just get my little camera and grab all of this so we can go and write with it. Okay, we'll look at it over here. And this gives me a chance to kind of draw on it, and we'll talk about this. So let's go through these notes here together. What does this say? So the first thing, these are the hints that you're given. So, we're going to walk through them. It says, suppose gear A completes A revolutions. So what that means, revolutions are, cycles. How many times does it go around? Right? Because the more times it goes around, okay, then it's going to turn this device more often. But what we know, they asked us to use the letter A to talk about how many turns this one makes, and they want us to compare it to C. So it says write an equation that represents the relationship between the number of revolutions A makes and the number of revolutions C makes. So A and little c are the variables they asked us to use. And it's going to be an equation, so we're going to use an equal sign in here, and we need to come up with something for that. So let's walk through the thinking they gave us here. It says, suppose gear A completes A revolutions. That means it goes around A times. So A times. Now, how many teeth of gear B does it move? So, well, for each one of these revolutions, it has how many teeth? It has 7 teeth. So in one cycle, it's going to make 7 teeth. So it's going, if in A cycles, it would be 7 times A, right? So when gear A completes A revolutions, it has made 7 times A teeth movements. Does that make sense? Because it has moved 7 teeth. These are called teeth in a gear, right? These are called teeth, in case you didn't know that. Okay, these are the teeth. And there's 7 of the teeth. And so for each one that goes around one revolution, that would be 7 teeth that have moved. And then we would, because, it's changing 7 at a time for each one, so 7 times A. There's that word each again, which tells me I'm going to have a constant relationship where I'm multiplying the number of revolutions times the number of teeth. So 7A revolutions, but how many teeth of gear B would that move? Well, it's also going to move, you see it's locked up 1 to 1, it's going to lock 7, it's going to move 7A number of teeth. Whatever A was times 7, that's how many teeth moved here, right? Then that's exactly how many teeth are going to move for B. All right? And C is also, it even tells us here, look, it says gear B moves 7A teeth, and gear C also moves 7A teeth because it's a machine. When this tooth moves, that one has to move, and when it moves, this one has to move. So we have the gears moving, in this case this way, and then that would move this one, I don't know, what do we say, this way, so that moves this down, and then that's going to drive this guy down, and that drive this guy around this way, okay? So this one's going to go that way, and then this guy's going to come back down this way, okay? Now, how many revolutions of gear C are 7A teeth? Well, gear C has 6 teeth. So now, if you think about it, because there's 7, we're going to move 7A times, but to turn that into a revolution, we have to take that product, 7A, that's how many times it moved, and we got to divide it by 6, because every time 6 teeth move here, every time we go around 6 teeth here, it's going to complete 1 revolution. So if we're thinking in terms of revolution C, right? C is going to move 7A. I mean, the number of revolutions is going to be however many teeth moved, but then divide it by 6. Okay, so if it's made 7A revolutions, we divide it by 6. That tells how many times this thing went around. Okay, so there's our little equation there. And you could multiply both sides, and you get 6C equals 7A. That's all they did, was they converted it. So that would be our answer here. I'm going to just put C equals 7A over 6. And I think that that's enough. The relationship between the number of gears, revolutions, gear A completes A, and the number of, so I'm going to put in this one, C equals 7A over 6, because that is the first one I thought of myself, and I'm not going to convert it like they did, okay? C equals 7A over 6. So when I put that answer in here, C equals, I use parentheses to show the 7A, and then that whole thing is divided by 6. And actually, do I need to? Well, it doesn't really matter, because to be honest with you, 7 times A divided by 6, it's all, that same order of operations, and that means I could do it in any order I really want when it's all multiplication and division. They're equivalent, and so I'm using the parentheses, but you wouldn't necessarily have to. Okay? Let's check that answer. And it didn't like that. I used a capital C. There was a little message in there if you looked, and it said some of your variables in the wrong case, upper versus lower, so I had to use a lower C. And that was fair for them to ask me. So now here we've got another one. This one says, let's get another page going here, and we'll go back in, and let's get another screenshot, and we can think about this one over here. And here we go. So it says Grayson starts with the savings account, or starts a savings account with $800. Okay, so let's draw a little picture of that. He's got some money, and he's going to put it in the bank, and the amount of money he's got is $800. So now the savings account has a 0.2% monthly compound interest rate, which means the account grows by 0.2 each month. Aha. So let's think about that. It's a factor of 0.2%. A factor of 0.2%. And so this is 0.2%. So we would have to think about 0.2%. This is 0.2. Percent means over 100. So if we wanted to turn that into a decimal, we need to move this 2 more. So that's 0.002. That's the factor that we're growing by. Okay? And remember, we're going to raise that to a power, because every month we're going to take whatever was there and we're going to multiply it by 0.002. The next month it's going to continue to grow. This is what compound means. Is that at end of month 1, this is our first, like we did with the rabbits in the generation. This would be my first generation. I have 800 times 0.002. And then at the end of month 2, I've got those 0.002 added in. So let's think about how we would do this. So what we'd say is let's take our $800 and let's times it by what? Well, we want 1 plus 0.02. Oh, it's 0.002, sorry. And then what we're going to do is we're going to take that and we're going to compound it, right? We're going to compound it. And so I think we can do this by saying, to the x power. If I was doing a graph and I was showing how much was in there, I'm going to have my $800. That's what this represents. And then I'm going to, add in this, or I'm going to multiply by this amount, whatever this turns into. And this is growing by a factor of 2 each time. So let's think about how that would work. Let's just make sure. 0.2% per month. So if I had $800 the first month, or when I put it in at month 0, I would still have $800. At month 1, I would have $800, okay, and I would times it by 0.002. So I wonder what that is. Do I have my calculator here? Let's put it in and make sure that it makes sense. I think it's going to be like a penny or maybe $1.60. Let's try that. 800 times 0.002, and it is $1.60. So that's pretty good. 0.002 is $1.60. So let's put that in there, that this is $801. Let me get my pen back here. So we're going now $801.60. But what about that second month? Well, now I'm going to do 0.002 times what? The 801.60. So I better think about that. And let's go 801.6 times 0.002. And now that pays me $1.60.32. Ooh boy. So that's going to be 803.20.32. That's not really a point there, but that's to just say I'm including that part, right? So 803.20, that's where I should be after 2 months, right? And then we would take our, we'd add that to 801.60, 803.2032. And then I would multiply that by 0.002 because that's how much it would be. And the next month I go 1.6064. So I'm going to add in 1.6064, and I should be at 804.80968. So it's almost 81 cents after 3 months. Okay, and that is just me showing you manually how we calculated it. Now, would that work? Let's see what happens if I raise this in by the power. So I go 0.002 times 0.002 times 0.002. I don't think that's going to work. So what we have to do is we have to get our I need to get our formula in there, and the way that works, let's just think about it. It is the number of times that we compound goes out here. So that is x goes out here. And the way that this would work is we take the rate and we usually divide it by n. Okay, but we already have that it's monthly. And then, okay, I got this. I'm going to help you here. Okay, we're going to think about this. Here's the formula that we actually use. Okay, I know the formula. We take the principal and then we multiply it by 1 plus, and then we take the rate and we divide it by the number of times it compounds. Okay, and then we raise that to the number of times it compounds times the number of years that we're going to compound it by, y, or sometimes they'll say t, the term, the length of the period of time, the time that it stays. So here is the number of times compounding per year, and this is the number of times also. It's the same variable. So in this story we would have P is the principal, that's the amount you begin with, so the amount that we have is equal to 800 times 1 plus, our rate is given as our rate was given as 0.02 per month. So we're going to have to just put that in, 0.2, as the rate. Okay? And then instead of thinking of it as it's compounding every month this way, we're just going to have to do it like that. And by the way, this R always says just put in the rate. Don't worry about the percentage. So we're not converting it to a percent. So we're just going to put 0.2. We're just going to say it's compounding every month. But then we got to think about how many times that's actually going to work. So if it's every single month for 5 years, that's going to be 12 times 5. The reason I'm doing this is because I'm not finding the annual rate unless they gave it to us here, and they didn't. So I've already divided it by 12 to get this monthly rate. So I'm not going to put in 12 down here. But I'm going to think about that it's going to compound 60 times. So here we go again. So the amount is equal to 800 times 1 plus 0.2 over 1 raised to the 60th power. That's how it's going to go over the entire 5 years, right? Compounding. So let me one more time in red. Let me get this again over here in red. Our answer, it says which axis should represent the number of months that have passed. That will be x-axis. I'll use that. That's good. And then it says potentially mathematical variables can have any value, but the variables under discussion here are bounded by the real world context they model. So what is the range of valid values for the number of months that have passed? Well, it could be 0 months that have passed, but if it's going to be for 5 years and there's 12 months at a time, so 5 times 12, it's going to go up to 60. So wow, is that all we were supposed to answer on this problem? Because then we don't even need this formula. But this is good that we've talked about this. This is one of the most common exponential problems you're going to run into, is the problem of compounding interest. And some of you guys have already seen these problems when we talked about interpreting the structure of expressions for that exercise set. You would have seen this already, and you had to answer what's going to happen with R if it's positive. Well, then it's going to grow, the money's going to grow. And if R was negative, we had a negative rate, then it's going to decline. And N represented the number of compounds, right? How many times a year it compounded. And then T or Y over here represents how many years that it's compounding for. So in this case, we say, what is the range? The range is 60, okay? From 0 to 60. So that would be my answers to those questions. Let's see if we have, that's all they want. All right. The number of months that have passed should be on my x-axis, which is the horizontal axis. And the range of valid values is between 0 and 60 months. All right. So that's how that's done. Maybe I'll do one more. Why not? Let's do one more. I'll try to be quick on this one. This one looks like maybe we could do it quick. So a basketball player has 2 free throws. Which of the following graphs describes the relationship between the player's probability to make a single shot and the probability of making exactly one shot of the 2? Aha! So we have probability of making one shot down here. Is you notice, probability is listed, the scale goes from 0% probability, and 1 represents 100% probability. So our probability of making one shot is somewhere between none, he's not going to hit it, or 100, he's definitely going to hit it. And then over here, what is the probability that he hit 1 of 2? Exactly 1 of 2. So that means he'd have to, make 1 and miss 1. Well, the probability of making the first one, let's think about this. If I had 100% probability of making my first shot, does it make sense that I would then have 100% probability of missing the second? Because this one right here I can pretty much rule out. Because this says I have 100% probability of making my first shot at this point right here. See that? And then it says, and the probability is also 100% that I'm going to end up with just 1 out of 2. Well, that means I would have to definitely miss the second shot. That doesn't make any sense at all. It would seem to me that the greatest probability of making exactly 1 over 2 would be in this range here, when I have 50% chance of making the first and a 50% chance of making the second. In which case, my graph should get highest right in here at 50% and 50%. And then, as it increases the likelihood that I'm going to make the first, it's going to decrease the likelihood that I'll only make 1, because it's more likely I'll hit the second one too. So it's going to, when I don't make the first, it's not very likely. If the probability is not good that I made the first shot, then it's not very likely I'm going to make the second one either, and so the probability is very low. But as the probability of making the first one reaches 50%, then it should be a 50% chance that I'm going to miss the second one. and that would give me 50% chance that I'm going to be there. I can just look at these and see that this doesn't make sense, right? If I make that first one 100% of the time, then I'm not going to miss it 100% of the time. Here it says, if I miss the first one, I have a 100% probability that I'm going to hit the next one. That doesn't make any sense either, right? And this says if I hit the first one, then I have a 0% chance of making the second one. Now that missing the second one, that one actually could make sense, because if I've made the first one 100% of the time, I should be making my second one 100% of the time, which means missing one isn't going to be part of the equation. Okay, you following this at all? This is, I kind of wish I could just, let's see if I can just annotate on here. What this is saying to me, this one says, what is the probability that I make one, and I miss one in any order, right? I make and I miss. What is the probability of that? Okay, that's what we're graphing here. And again, the more likely you make one, the less likely you're going to miss one. If you're really likely to make one because you're very, very good, you're not very likely to miss one. And if you're not good enough to make one, you have like no chance of making the first one, then what chance would you have if you're going to miss the first one, 100, almost guaranteed you're going to miss that first one, then how would you have any guarantee you're going to make the second one? So to me, this one is the only graph that makes sense, okay? And for the reasons I've explained here. So I'm going to go with graph 2. Go back here and hit graph. Oh boy, I need to go back in there. Let's go to graph 2 and check my answer there. There we go. So that's how those are done. I'm definitely not going to do a third one for you right now, okay? That's what you got to work. Oh, this is the one we just did before, so you kind of have an idea how that's done anyway. Okay, get working on it.